Hey guys, how's it going? Um, Today I wanted to talk about section 3.3. Basically, it's solving inequalities by multiplication and division. So it's pretty much the same thing as with equations, but there's just one major difference. Okay, so basically, just like this was an equal sign, if I had 3x equals negative 27, the way I would solve that is I would just simply divide, right? So I would divide both sides by 3, getting x is equal to negative 9. Well, over here, I'm going to do the same thing. I want to get the x by itself, so I want to divide by 3. So that's actually not changing, right? So basically, I'm going to get x is greater than negative 9. So graphically, here's the 0. Negative 9 will be basically way back here somewhere. I would have an open circle at negative 9 because it's not or equal to. Greater than, I would shade to the right. Okay. Now, so for the most part, it's no different than if it was an equal sign. Okay. I will get into the difference in a second. We would solve this one the same way we would do if this was an equal sign. How do you get rid of this 2/3? Remember, we're going to multiply both sides by the reciprocal, right? 3 over 2. So the x, that cancels. I have x is less than. Remember, the easiest way is divide by the bottom number times by the top. 6 divided by 2 is 3. 3 times 3 is 9. So x is less than 9. Okay, again, we can graph that. Here's 0. 9 will be way over here. It would be less than. I'd have an open circle because it's not or equal to, and I would shade everything to the left. Okay? Now, let's get into some of the differences, though. Okay? Well, let's do a couple more examples first. Let's do the differences. So, the difference here is what happens when you basically have to divide by a negative. Okay? This is going to be the biggest difference. And the reason is this. We would all agree that 8 is bigger than 6, right? But if I multiply both sides by a negative number, okay, let's just take negative 2 for example. Well, negative 2 times 8 is negative 16. 6 times negative 2 is negative 12. Well, negative 16 is actually less than negative 12 now, right? So what ends up happening is when you multiply by a negative, the sign ends up switching as well. The same thing holds true when you divide by a negative, okay? We know that 10 is bigger than, 12 is bigger than 10, right? But if I divide by negative 2, so I get negative 6 and negative 5, well, now that negative 6 is less than the negative 5. So my signs have to switch. And the same thing holds true with negative numbers. If I just take an example of negative 14 and negative 10, and I multiply or I divide this by negative 2, well, right now, that negative 10 is bigger, right? But if I divide by negative 2, now this becomes positive 7. This becomes positive 5. Well, now, again, the sign has to switch. So basically, our rule is going to be if we ever multiply or divide an equation or an equality by a negative number. In this case, I'm dividing by a negative 4. Well, when I do that, I just divide normally. 24 divided by negative 24 divided by negative 4 is going to be negative 6. But I have to remember to flip the sign over, okay? The biggest thing is if you ever multiply or divide by a negative number, okay? We don't care whether this number is positive or negative. We care about the number that we're multiplying or dividing both sides by. If this happens to be a negative, then you have to flip the sign over, okay? Let's try another example here. So let's take this one here. Well, I want to get the x by itself, so I want to get rid of this 4/5. So I'm going to multiply by 5/4. Now, the 5/4 here, the number I'm multiplying by, that's a positive number, right? So that means I'm not going to flip the sign over. We'll leave that alone. The x, all I have over here is x. Over here, I could cross reduce. Those 5's become 1's. The 2 and the 4, right? And a negative times a positive would be a negative, and I'd get 1/2. This would be my answer, okay? And yeah, I can graph that one as well. Let's try another one. All right. This one, I want to get the x by itself. So in this case, I want to get rid of this -2/3. So I'm going to multiply both sides by -3/2. Now, in this case, the number that I'm multiplying by happens to be a negative number. That means this sign has to flip. Okay, so the x is over here. Again, I can cross reduce a little bit. That 4 and 2 reduce, the 3 and the 9 reduce, multiply now, and I get 2/3. Positive times a negative ends up a negative. Okay, again, we don't care whether or not this number was positive. We care about what is the number that we're multiplying or dividing by. If this number is a negative, then we flip the sign. If the number that we multiply both sides by is a positive, we're going to leave that sign alone. Okay? That is by far the biggest difference with solving these. Let's try a couple more. This one here. Well, I want to get the x by itself, so I'm going to divide by -8. The number that I'm dividing by is -8. That happens to be a negative number, so that means the sign has to flip. 72 divided by 8, -9. We don't care whether this is positive or negative. We don't care if the 72 is positive or negative. It's all about is that number, the number that we're multiplying or dividing by. Okay? Let's try one with the x's on the right side over here. Well, in this case, I want to get rid of that -5. So how do you get rid of a divide by -5? We multiply by -5. So we're going to multiply both sides by -5. Well, I have my x on the right side now. 5's cancel. I'm multiplying by a negative, which means that sign has to flip. Over here, -5 times -3 would be +15. And we'd be done. Okay? Again, it's all about is the number that we're multiplying or dividing both sides by negative. We don't care whether the 3 is positive or negative. That doesn't affect it. Okay? We could also run into some story problems. Okay? Got to make sure we can take the words, put them as an inequality. Product means times, so the product of a number and 7. So 7 times a number, I would just write 7x. You could write x times 7, but it doesn't matter. Now this says is not less than. If it's not less than, that means it has to be greater than. Now, this would be greater than or equal to, because if it's not less than, that means it could be greater than, but it could also be equal to. And then, how would you solve that one? Well, we would divide by 7. Now, because we're dividing by a positive, we're going to leave that sign alone. And we'd be done. Okay, let's try one more. Quotient means division. The quotient of x and -6. Well, that would mean I'd have x divided by -6 is at least. Well, that means it has to be greater than. Okay, if it's at least as big, it's greater than or equal to. Okay, because if it's at least, that means it's greater than or equal to. Okay, we put the 5. How would we solve that? We get rid of that -6 by multiplying by a -6. Because we're multiplying both sides by a negative, that means that sign has to flip. Okay, so that's the biggest thing. The only real difference between solving these inequalities and solving regular equations is if we ever multiply or divide both sides by a negative number, We just got to remember to flip that sign over. All right. Well, try a few of these and hopefully they go well. And let me know if you have any questions. Talk to you guys later.